Hi everyone. Today we are going to have a workshop. In this workshop, we are going to learn how to fine-tune LLMs. I'm really excited about this because I personally don't have any experience with that. So along with you, I'm going to learn. Maybe some of you already know this, but for me it will be something new. So I'm going to learn this. Um, I'm going to make sure I'll ask Ivan all the questions I have. And also, what I should mention, so this event is brought to you by Databricks Club, which is a community of people who love data. We have weekly events. If you want to find out more about the events we have, there is a link in the description. Then do not forget to subscribe to our YouTube channel, like this video, tell your friends about this, and we have an amazing Slack community where you can hang out with other data enthusiasts. If you have any question during the workshop, use live chat to ask your questions, and then periodically I will try to gently stop Ivan and ask the questions, these questions that you ask. So yeah, use the live chat for that. And with that, Ivan, the floor is yours. I'm really excited about that.
Thanks. Uh, I maybe give you a short intro, like a little bit overall. So fine-tuning of LLM actually comes from prompt engineering. I would say you start from prompt engineering, and there are like many techniques which you can apply, and each next one like more complex, but you basically start from prompt engineering. If it does not work or you get not enough results, you can move to soft prompting. You can do LoRa's fi, fi, fine tuning. Yes, I can send you my GitHub repo where it is. Tin, tin, tin. Um,
And also maybe to this collab, because people ask if they can have it. So if you can also share it, would be
yeah.
awesome.
This is original blog post which I did on the results of those experiments, and okay,
But please send it to Zoom. You will not be able to share it in live chat.
Okay.
Yeah, because YouTube
Mhm.
only allows the owner of the channel share it. It's
Okay.
anti-spam.
So this is I said in Zoom. This is
Yeah, so I just
collab,
shared.
and this is actual blog post with some like text details about whole approach. And okay, I lost my here. So there is several approaches. I go back, soft prom, LoRa. Soft prom basically it's fine tuning of several weights. So each next approach dif differs in amount of weights you're fine tuning. So assumption is you prepared some data for this, so you have some relevant pairs of completions. Yes, so with some references which you want to make LLM prefer to another one, or maybe your LLM is missing certain specific domain knowledge or text. I don't think you will run into like if you're talking about English and some tokenization problems, we are not covering it here. It's more about given tokenization of any LLM you are using, whatever quality it is, you want to improve behavior of LLM. So those techniques, when you take certain fraction of parameters. Soft prom is like smallest one. It's actually very similar to image generation text inversion technique. So also there is some vector which you fine tune, which you can concatenate with original prompt. So those techniques are basically rated in increase of amount of parameters you fine tune. Uh, I did not cover here instruct DPO fine tuning because with LoRa it gives very little improvement. So instruct fine-tuning, it's more when you want to change type of behavior. So it's more into reasoning models. So here we are touching what you really can do basically on your work computer or CUDA home or whatever one instance thing. Because whatever you take big language model and you want to do full fine tuning, you are going to have a pretty huge optimizer state, and it's not really feasible. You need to go into distributed training, which will take you to like it also will cost way more. So we are covering those techniques which you can do on your local machine, basically with CUDA, one CUDA or even couple maybe. uh, to apply all those techniques, you need to have certain data set. I'm using here like Dolly, Databricks, it's 15K examples, which improve instruct basically, but you also can use them for supervised fine tuning, for soft prompt. You also can create your own if you have some, I don't know, agent with traces. You can annotate those traces and turn them into dataset and apply as fine tuning. I assume
And
like
can you tell us more about this dataset? I'm just Googling it right now. So this is Databricks Dolly 15K, but what is it about?
it's just some
Question
examples.
answer or
There are some
dataset?
examples of this dataset. So it's like questions. When did we
Why
train?
mobile is bad for human? We're always engaged on phone.
Yeah. So
Category
it's just
brainstorming. Okay.
simple templated. Like we go through a little bit more details about template because might be not everyone knows like everything. I prepared certain structure, but this is basic like pairs, like some system prompt in instruction and response pairs.
Mhm. Okay. You'll tell us more about that, right?
Yeah.
Okay, good.
We go through this. It could be any. I was trying to do like data set agnostic because you basically multi-turn or two turns or one turn data sets way for LLM. The differences in template mostly. Also, maybe with some loss functions, with more focused on certain parts of completion of prompt, but basically, whatever you have reasoning model, from reasoning model, you have just different text, what you take your data. Pam pam. This you can run it on CPU. I took a very small language model, and I also in this example I used only perplexity basically. So next token prediction improvements in blog post. I covered also like. Generic capabilities like multi-turn structure, etc. There are many benchmarks you can use, but you start from perplexity. This is how
Mm.
supervised fine tuning works. So
So
basically,
perplexity is a metric that we optimize, right?
yeah, it's like next token prediction, and on
Hmm.
when we have pair of text, so we do prefill for prompt, and after we start to predict in each token what we are predicting, we are measuring how correct we predicted it. So, and perplexity based on quality of next token prediction, we don't check more high level losses. We can do regularizations, etc. But basically, we start from very simple, and in most of cases, it actually works. So you just do pre-train LLM, you take pre-train LLM, you take your data, and you adjust LLM probabilities to predict next token. And for example, you want to introduce in your output new token like HTML kind of token. So how you mark something, or you want to make it like only JSON. You want something in input of your model, like you can mark something like this. I better show like your input. Imagine like something and you want LLM to respect this tag. And you want to extract from this tag certain, I don't know, entity or whatever. It could be like red. And you want your LLM to react on this tag and produce certain structured JSON. You can create this data set maybe with 2K, 4K examples. You do fine tuning with next token prediction, and it gets pretty good quality. You can reach like F1, like 99% uh, round with very good precision and recall also. So we think of SFT. If you create right data set with not very much data, not very much compute power, you really can get very good results. So you can start to use like small model and get something quality of you get from like I don't know, O3 or whatever.
Mhm. And I
Okay.
see that here you use a small model, right? What kind of GPU do we need if we want to go with Qwen3? Do we need
For Qwen3, I think for LoRA up to 7B or 8B, you can fit in like 30 gigas if you
like
use
if I
quantization.
use collab, will it be enough?
Yeah, you can, but it
Oh, right.
might be take more than 20 hours, and Collab is not super handy
20 hours. Okay, okay.
because sometimes session is gets
Yes,
stalled,
they
and
do.
so
Yeah.
yeah.
So if I use
So
something like Saturn Cloud where I can make sure that sessions don't
mhm.
get killed, then I can go with a small GPU like we have on Collab, right?
Or you can use some, I don't know, like weights and base, some model repository, so your snapshots are persisted somewhere also when you can do it with collab, but you
Yeah,
you
I
need to
see.
use some persistence for
Yeah.
model weights. Yeah, so this was run on CPU. Like
On
you
CPU. Okay, that's great.
yeah, but model is like is very small. I just wanted to show that if you apply this like next token prediction, you basically can get some results. You can for point 0.6 Qwen, you can with quantization you can use like 40 50 gigas CUDA, and you have chance to do some full fine tuning depending on batch size, depending on your attention, etc. So there are many compositions which you, I don't know, it makes no sense to give any guidelines. You just try and you see like you out of memory and you align it. But basically, what you can do is batch size. Batch size versus like attention. Those two main, depending on your size of input and depending on type of attention of model, what you fine tuning, it can behave very differently. Uh, this notebook you can run on CPU just to experiment and see some tiny changes. Also, there is like as I said, blog post and repo with CUDA examples. You can go like something more complex, more efficient. So, bum, bum, bum. Tokenizer, yeah, again, we assume that we are not touching tokenizer. Actually, Qwen tokenizer is pretty good for multi-language models, so you basically don't need to touch Qwen for most of European languages. It was pretty good. You don't have much of like tokens, word split cases. It does not affect much quality of it.
And even
But
for
if you
German, like in German, you have these compound words. Do you still need? Do you still can just use the
Qwen
pre-trained
works
tokenizer?
pretty well.
Okay.
Like, I don't know, my experience is pretty good. Da-da-dun. Yes, we use like a casual language model, which is like next token prediction. We have also another like branch with BERT, but we are not covering it here with encoders. We cover here only generative models. Tam, pam, pam.
What happened in all this code that you just scrolled through?
It's some helpers code. Here we extract from dataset because we have instructions, context, and response reference.
Mm.
So we need to extract it and make it. Here we create chat template because I think it's like OpenAI now standard way introduce those roles. So there is some like list with roles which translates into template with text.
Mhm. So system is the system prompt, right? Then the
Yeah,
user, this is what
usually
the user
we
sends.
can see it here
Okay.
because each role has its like token name. So this is like convention where some of them different. In Qwen, it's slightly different. It's also thinking different models. They can do different type of templating, but basically those im start is usually one token. So language model knows that this is separation of terms of reference.
Mhm.
So when you go through it, language models like they react specifically on those tokens. They are more significant than other, for example. And for system token also you can force model to respect it more. It's like on pre-training phase, it's usually with some additional losses. Now we know like there are multiple losses. We don't cover it here, like, because it really depends which loss was used on pre-training phase, how model reacts on certain tag. We just take whatever it is and we observe and we can like it or no, but this is we cannot change it much with partial fine-tuning of tokens of parameters. So if we want to change it, we need to do full fine tuning because usually like LoRA is not enough or it can break or behavior is not going to be very pleasant. Okay. Yeah, there are some like helpers. It's basically OpenAI introduce this type of template and this type of roles, and this is like API. Like now it's mostly everywhere, but anyway, some models so they change, adjust a little bit for the cases. Okay. Yeah, those examples, so we just compile into like because eventually model does not really care about your reference or system prompt or whatever. What model does care is some sequences of tokens which it gets on prefill phase. So this is your prompt, and after it starts to generate it with certain heuristics like beam search or whatever. So we are not covering here inference also, but it's something what assumption is you should know. Так, so chat template we cover. So you can use Hugging Face tag. It's mostly enough. Only for very specific cases, you need to go to PyTorch because transformers, SVT trainer, etc. They hide PyTorch model as abstraction. So you can set for LoRA certain exact layers. You can extend layers. If you have more compute, you can add more layers which you're fine tuning. Also, you can play with rank of matrix of weights. I think we will cover a little bit more details later on. But basically, you can be fine with Hugging Face. You can do like almost everything out of what I am covering here with Hugging Face tag. And apply chat template. It's standard practice. It knows about type of your model. It knows which template was used on pre-training, and you just give your messages in this format, and rest type of template applied by Hugging Face transformer according to actual templates which were used on pre-training phase. Yes, you can ask for tokens, so you can get text. It's like for debug reasons. So you can see you get those messages with roles and context, and you get this ready to apply templated text. Okay. KL divergence, it's like a regularization technique. It showed itself very efficient, but it's also pretty simple. Here I try to give you intuition. If we have 1, 2, 3, 4, 4 tokens dictionary. So this KL example is 4 tokens different, 4 tokens dictionary. We assume our LLM is very, very small. So each LLM has output with probabilities for each token. So if we have very small output, when we can say, okay, now we are having a reference model which we freeze weights, and we have like students model which we are fine tuning, and we want our fine tune to not go that far. By the way, LoRA by itself is kind of encapsulate regularization techniques because it changes only certain weights. But you can apply on top of it, you can like bound it, like strict, so your weights are not going too far. This way, you can assure that foundational capabilities of model are not touched by your fine tuning, and your fine tuning process is gonna search for more soft change approach. So you have in this example, you have student and reference model, which you are fine-tuning probabilities of those 4 tokens. And here is example how you can estimate KL divergence. There is forward, and in worst KL divergence term, but they a little bit differently influence. There is like even research on this, but here is example what is KL, because KL moved DPO and fine tuning on new level, because it also uses an image generation, because it's pretty funny that language model and image generation they use pretty similar techniques in certain, and now they even shifted into like transformer type. So they substituted usual UNet backbone with transformer, and now we're like almost same, I would say. Okay, KL is like it's like you can see it in this code. I hope it's like super intuitive. You just compare differences of student and teacher for each and reference for each token. You get this log of this cross entropy, and you estimate KL, and you sum it up, and you see what direction student goes from reference. And it can, so basically in loss function, you can apply additional term to not let it go too far. I'm not looking too much into this because I think it's too much mathematics, but KL is like, it's pretty important to understand because it's like everywhere. Okay. Now we start from soft prompting. Soft prompting is just one vector which you can concatenate to model. Also, you can. It's basically LoRA. It's very small LoRA, but it applies on less parameters. So each parameter, if you fine tune, it should keep a certain state of optimizer in memory. So whatever you're fine-tuning, amount of parameters you're fine-tuning, it's your burden to your memory. You need to keep this state. You can apply several techniques of optimization, but if you want to fine-tune big model, with soft prompting on your personal computer, you might be able to fine-tune Qwen3 billions of parameters with quantization. You quantize parameters of model, and you apply this to your training parameters, and you keep only for those parameter state. This is cheap technique. And here, in example, it is also done with transformers. You just need to use like interface prompt tuning config. You set type of your model, you set number of tokens you want to fine tune. It's kind of number of parameters. You also set your initial prompt because you need to set something which directs model, and on top of this, you're adding your tunable parameters. And given you already have some reference data, so you have some positive, negative results, you just fine tune this small amount of weights, and even on this setup, you get some improvements out of like 20 steps.
I have a question about that. So
Mhm.
when do we use this? So do I understand correctly that, let's say we have an LLM for a certain task, and usually when we have a task, the task has instructions, the task has user input, and there is some output from the LLM, right? So instead of putting the instructions, the system prompt to the LLM every time, here we include it in the model. So then next time we don't need to send this system prompt,
I
right?
would
So we
say,
goes
mhm.
directly to the user input, right? Or I misunderstood.
Yeah, it's not exactly into your text, like, but it can be like there are many different techniques you can just concatenate after embedding layer, after attention, or there are many types. You can plug in it any place of
But what's the use case? So when do I use this soft?
I think use case is a few short optimization. Some when you do your prompts, you also can do few short context. And there are techniques how to optimize those few shorts. Which examples you add to your
What is
prompt.
few shot? Can you give an example, like more concrete example?
When you write something and you give examples, okay,
That's
if
sentiment
this
analysis,
is
right?
input. Hmm?
Okay. Sentiment analysis, for example, we can say, okay, this is positive, this is negative, this is positive, this is negative,
Yeah,
right?
follow these examples.
Yeah.
If user do you do this that, and zero shot when you don't present any examples. Yes, few short examples when you provide certain reference examples of user queries and responses. For example, before JSON conditioning fine-tuning, like couple years ago, it was pretty difficult to make model respond with JSON. But what you could have done is you say, okay, on this question, like which is the capital of Germany, and you give example of response in JSON, like city, Berlin.
Mm.
And you provide several examples. So this is few shot.
Okay, and
Uh,
then the model will respect the schema, right? It will.
yeah, but also there are also some problems if you give those examples, your models start to use them as guidance, so they can overguide it. So with soft prompting, you basically can mitigate it by creating certain data set with those references and making model prefer what you want from it with cheap computational cost, basically.
Mm. There is a question: how to select a number of virtual tokens, and what is virtual tokens? Maybe I missed that.
It's here. It's
Okay,
prompt tuning config. Uh, I think we can go to documentation. Uh,
so PEFT is a library from Hugging Face, right?
yeah, it's all part of it.
Do I need to install it separately, or I get
Yes,
it with transformers?
at the beginning, all dependencies are stated here.
Okay,
You
so
need to.
transformers, TRL, PEFT, bits and bytes. Okay, safe tensors. Okay, some of these
It's
things
for with
first time I
some
hear.
expert, not super
Okay.
standard or something. Okay. Yeah. So there is the combination. I would not like for myself. I just don't have actually usually I don't follow like very strictly certain numbers because I start from something after I change and you basically see when you change in right direction when you can try more you need to set up certain experiment baseline so you need to set up okay before fine tuning I want to track those metrics and you freeze them on your data you split your test for test set and train set and you run on test part okay and you freeze numbers you outline metrics and you freeze them. And after you start to apply, okay, you start from whatever random number, and you see. And after you see, okay, if I increase it with same steps, my baseline improved better or worse. So and you set up this experiment you fix data and you start to tune your parameters. You could change maybe batch size. There is there are many also quantization. You can experiment with int 4, int 8, int FP 16 for parameters for optimizer state also there are multiple things you just need to set up experiment and you need to try to apply different and you see numbers if you try to go with certain guideline you might miss for your specific case because it's not much rules. You just set up experiment, outline baseline, and try to optimize your metrics. You might need several weeks or months, I don't know, to get use of your data. Might be many iterations, but be open. Sometimes very unexpected works. When you increase LoRa rank, you reduce regularization effect of LoRa, for example. So depending on your case, for some cases, when you want just very light structure alignment, it might be enough. But for some cases, when you have very specific words in your dictionary, like I don't know, you go so biochemia or some medical vocabulary, you might have different setup for your different domains. Just try different Google for approaches for your domain, and it makes more sense. Okay.
Yeah. So basically, your suggestion is set up a validation framework and then try different things.
Yeah. You need to set up classical ML pipeline, experiment baseline, and you do your experiments, you stack up your numbers, and you see which one is better. Uh, what I would suggest, more complex your task, you need to also add some benchmarks for general capabilities of your model, because what could happen? You could break multi-turn quality, or like, but again, it might be fine in your case. So it's like very huge topic. Here we're just covering basics, so to get started. Okay, so soft prompting more or less covered. Pam pam pam. Mm, Supervised fine-tuning, as I said before, it's like next token prediction. Like instruct, DPO, it's like reference we've rejected, and it's like more complex loss basically. And also reasoning models, there are different levels of your loss you can apply, because when you have multi-turn like DeepSeek, we actually apply this group loss. You estimate loss for each turn, and you have a more high level of all success, and you add certain heuristics. So depending on your case, whatever you want to, for example, do coding or like software engineering alignment of model, maybe for your very specific case, when you need to go into more details. Here we are covering like more structured. So those techniques are fine for structure, for styling, maybe for some preferences when your LLM is not stable, even with low temperature, or you want to experiment with higher temperature, with so to make it. So when you want to stabilize your output, or you want to add a little bit of new lexics or type of behavior, whatever you want to completely change, you want very specific model for certain specific case, customer service, or whatever, you might need to go to full fine tuning. But again, if you want small model, you might need it. But bigger model, again, the first technique could be fine. So in each case, you need to do remember of multiple trade-offs here, and depending on this trade-off, you do. Okay, here we are coming to LoRa. When we fine-tune LoRa, we need to set target models. It's like certain layers, certain like because what is model is like stack of dictionaries which contain weights, and you target certain models. You can add more models here. You can add all of them technically. And so depending on your resources, and again, your computational resources, those parameters of fine-tuning you're applying. You can increase, you can decrease, it's pretty up to you. But what is important is LoRa rank. Sometimes you just like need to change, like check like 16, 32, 64. Sometimes you go to 128, and it makes sense. Sometimes it just gets worse. Because again, what LoRa is regularizational techniques because it keeps most of weights freezed by itself. So you set up this is like pretty standard training arguments. You can mitigate your lower batch size with gradient accumulation steps. So and checkpointing. So because like it's also like I would say all model training is like it's go to overfitting or regularization. So you apply regularization techniques like deep learning or even like simple linear model techniques are applicable. Maybe it's in more easy way because here you just touch slightly what already done by big companies and many peoples, and you just want to align it for your case. Collator, it prepares your data. So, you start your
What do you mean by prepares your data?
because Collator, it's standard interface. Basically, you're giving your data in text and it produces tokens. It's usually like I think it's like more or less everywhere. So it's something what takes string and produce tokens for which you fit into model. Because if you have too big data set, you might need some techniques to swap data. Because for this case, it's like it's not much, so there is no overheat here. But if you have really huge data set and you want to go through this, you might need to take care of it. Might hinder your performance of GPU. It might hinder your GPU resourceful consumption. Uh, okay, and we see here like it's also it learns it gets this loss next token prediction whatever you are presenting those instances it goes down. It's just very slight example, so to let it like touch more complex example is like in repo. Actually, repo where this notebook stays, it's like full repo, like SVT, DPO, like with more serious benchmarks. Here is just perplexity, like next token prediction. And for example, so we are getting from 284 to 278 with just LoRa. And we can also try to regularize this. So same LoRa, but we add additional term. So basically, we modify loss function with which we are fine-tuned with to keep our student model closer to reference model, not go too far. And we see basically it makes slower reduction, like so it slows down perplexity, like reduction. Why we want to do it? If we have, if we apply our data and we see that, okay, we actually overfitting it, or we want to keep certain benchmarks on good level, And we see that our data set is actually degrading better benchmarks. You can apply certain regularization techniques, and when you will see that when you are not reaching this. So it's nice to know it might be soft prompt or SVT LoRA is enough for most of cases, especially if you want to play. But when you will add more benchmarks, like example is instruct capabilities, multi-turn, reasoning, etc. When you will see that with SVT, with next token, it's very easy to start to degrade them. And to prevent it, you can add on SVT just KL, or you go further with other techniques. Here we take this and we just do inference. We are not covering production inference. I think production inference is not transformers. It's more like VLLM or even TGI stack, but here is just for examples. It's enough. And you see like soft prompt goes very fast. LoRa slower. KL even slower. So depending on your case, you choose your approach. I think that's it. Any questions?
Yeah, how do you usually, can you give examples when I want to look into this? So for each of these, like for example, this soft front, when I want to use this and with which model? So here you used a very simple model, right? Very small model.
Mhm.
I assume if I just ask it, it will be pretty bad, right? Like probably it will not be super good at doing things in general. But I assume if you fine tune it for your specific task, and this task could be, maybe you can give some examples of what this task could be, it actually performs better, right? So I'm curious to know what is your personal experience when you used these models for which use cases and when you recommend to use which of these things and with which models.
Like for sure, if you do some edge inference,
Hmm.
edge inference, like now you could have 6 gigas GPU, and for example, Qwen 600 millions parameters, you can fine tune for 300 megabytes of GPU RAM. And it kind of makes sense if you have some simple cases, for example, some kind of vocal assistance which has certain TPU on your edge device, and you want to do some simple command recognition, like simple like rise volume, down volume, not something you pretty can keep it in device. You can do it. So you have not long sentence, and you want to understand does it has command or no, and you can optimize your pipeline. And more complex cases, you can classify more complex cases like intent
Would we need
recognition.
an LLM for this
Hmm?
at all? Like for this classification, would we need an LLM? Like, is it a good approach to use an LLM for that?
It depending on data. If
Uh-huh.
you don't have enough data, then pre-trained LLM pretty good case because when you have can have very small data. Because if you really want to do it, you need maybe 100K or even million instances to train from sketch
Yeah,
with
yeah.
like lower parameters. Yes, but if you don't have like 1 million or at least 100K of instances, like yes, you can generate them, but it's also task. You might not cover all cases, but pre-trained model give you pretty good confidence with for this task. Why not? If you have 12 gigas on Snapdragon like 800, 900, why not to put it? So if you don't have competition for resources much, then you can do it. So if you have some box or whatever, now box of NVIDIA is like at least 30 gigas RAM. So you basically can do really much. You can put you don't need to have specific models, and if you able to use pre-trained models for this case, okay, like 600 for more complex, like for better quality, but it's like 10% of your memory. So you can afford it. But as what you can achieve, so some simple cases you can put on edge device. In this example, if you want to add some specific techniques, I added here like there is like that question answer data set to extract like from balance sheets, basically sum of tumbles or numbers of certain specific numbers from PDF. So you can fine tune it, and you can split. Here I did split, and basically you can fine tune on Reddit Finance, which is like and you can see that that QA also are improving. Also like finance instruct, etc. There is some specific for Qwen. It even good for Qwen3 because even Qwen3 are very specifically very broad, fine-tuned, and whatever you want to solve to do better your task, you can apply it. Or for example, TVX is like Russian language data set. So you want to improve other language performance on your model, and you can split and you can see, but there is 400K instances. Whatever you are applying, like straightforward S30 of TVX, you will see degradation in multi-turn performance, and you might see degradation in English. And here, if you start to apply regularization techniques, you actually can achieve improvements of your dataset performance without degradation of other capabilities. This I found pretty important. Also, TED QI is like open, close questions data set. It usually like yes, no, or select answer from Yanamchik, or from like number, give me number. And you can see this very structured, simple data set could improve if you also if you not applying it on fine tuning, but apply from same domain. This way, it seems like currently, if you have very specific case, you might be fine just generating more data instances, enriching your original data, or maybe translating to another language, and then adding it, like making your model good for same case in another language, because whatever you play with instructions answer in certain language, all models, like most of common crawl is like 50% of common crawl is English. So rest of languages they are underrepresented on tokenization level and on training data set. So you can mitigate it for your language. And here, basically, you can try to play its more serious experiments are here. Okay.
Yeah. And then another question that somebody asked throughout the session, I kept it at the end. So you said that LLM doesn't care about the previous output, but then the question was, how does ChatGPT remember? How does it maintain a conversation? So in ChatGPT, you ask a question, it answers, and then you can ask a follow-up question. So how does it work?
I think it goes more into agent patterns building, like memory and etc. You also can there are techniques actually to have memory with rel approaches, etc. But basically, you can plug in memory as tool as
Yeah, I
baseline.
think what the answer is not your answer is a little bit more complicated than the question is. So the question is within the same conversation. Like,
Mm.
how does it know that you like? Okay, within different conversations, you need memory, right? Because then it needs to know what you were talking about in the previous conversation. But you're continuing the same conversation, right?
I think, okay, maybe I didn't get question because here is like you have prompt. Usually all data sets were pretty strict. There is something what was presented and after what was generated. So there usually two parts of it.
Mm.
And what was presented is pre-filled in slightly different way. It just goes through without any types of beam search. It's kind of in greedy way. It just goes through to next token. And after
Yeah, I think
model start.
you're answering. So I think, well, let me try to answer that.
Okay,
So,
yeah.
so in ChatGPT, when you ask a question, you get an answer, and then you ask a question again. What happens? You send the entire message history back to the LLM.
Yeah.
So that's it. So
Ah,
every
okay,
time,
okay, yeah,
and at
yeah.
the end, when you, I don't know, talk to 1 hour to ChatGPT and say thank you, then the entire message history from this chat is sent again to ChatGPT. So be careful. Don't just thank ChatGPT because you are burning CPUs. So GPUs somewhere. So this is how LLMs. So LLMs, they are stateless. They don't remember previous conversations. So in order for them to, in order for you to be able to ask a follow-up question, you need to send the previous message history. At least this is how you do this when you work with API. So I assume when you work with a model that is in your GPU, you're doing something similar, right?
I think it's
Yeah. Like
good
it would be
here.
more messages here, not three,
Yeah.
but like another one. I
Wait.
see a question. What is the difference between LoRA and PFET?
Uh, LoRA, I think, is one of techniques. FET is parameter efficient fine tuning. PEFT.
Yeah, there was a typo and I read with the
Yeah.
typo. So I guess
Yeah, so it's and LoRa, there is Q LoRa, there is like many techniques and also soft prompting. It's so basically parameter efficient when you don't fine tune all of parameters. You just you have algorithm to select certain fraction of parameters to fine tune the rest of your freezing, and this is approach. It's name of I think there is paper I don't remember exactly. Yeah, it's like it started from. No, it's not 23. Maybe it is. I'm not sure if it's right paper, but basically they introduced this term with some first of techniques, and LoRa was one of approach, and after other types of LoRa popped up, and etc.
yeah, interesting. Thank you. Um, yeah, so for me, I now have a little more understanding of what is happening. I would still need to probably go through the notebook to try to execute everything myself. Mm, I don't have a GPU and I just have a simple computer with, maybe it's not so simple. I have like 8 cores. It should be enough for me to play with the notebook, right? To
Yeah, it's for CPU. So to run it on CPU, I intentionally because uh, I have like MacBook and on MacBook it's MPS, but most of techniques with quantization are not really good for MPS. So CPU is good enough. It makes no sense to like overcomplicate it. But whatever you want to do, play with big models, you need to do CUDA because simply byte and bits, etc., important quantization technique were not really existing for CPU, or even for MPS were not implemented for Apple Metal.
maybe so I'll run this notebook in order to then maybe one the next step for me. What should I do to like maybe I want to do a small project. Like I run this and I want to understand this topic more. What could this project be?
Select some open source data set, what you like.
Like, for example, which one can I select?
I don't know, Reddit.
But it should be in the form system prompt user message
Not
instruct, or
necessary. You can do like you don't really need to have with system prompt. You can have just user assistant multi-turn. Maybe start from benchmarks. Multi-turn. Uh, Empty bench. So basically, you can get this bench, you split it, or you can do these benchmarks, and you start to add any Reddit or whatever data sets. A lot of like Stack Overflow
Mhm.
for certain domain because they're really good because you can filter them on some subreddit, and when you get strict domain and you can experiment with this. If you have agent, you can collect your traces and you use LLM to judge them and you can apply this. So depending on time and effort you want to put, but start from benchmarks, select open source data set. If you covered it, try to generate synthetic data set, but this is gonna be more complex topic.
Can I use Slack data?
Slack?
Yeah. Like in Slack, you have
Why not?
threads, you have
Perfect.
responses. Should work, right?
Yeah.
Or
The
email
problem
threads.
is like you better start from like question answers
I
pairs.
see. I see. Yeah, I mean in Slack usually it's at least in our
Multi-turn is
community.
could be very 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 tricky for like better find something very simple to make it work and make it more complex iteratively.
I understand. Okay. But basically, it should be question and here's the answer. So Stack Overflow is a good example. Reddit, maybe we select the first comment, or maybe Slack, where for example, in our community, people often ask questions, and then the first message could be the answer, right?
Jira comments
Yeah.
also
Okay.
could be.
Oh, sorry, I have PTSD from my work. I don't use Jira anymore. I'm a happy person. Okay, Ivan, thanks a lot. Thanks a lot for answering all my questions, for explaining these things. I for sure have a lot of things now in my to-do list, thanks to you. Uh,
You're welcome.
so the list is already long, and now it's longer. Wow.
I think
Okay,
this
so
is
thanks.
time we anyway.
Yeah, and there was a lovely discussion also in chat. I see people are helping each other. So yeah, that was cool too. So yeah, thanks everyone for being active. And yeah, that's it for today. Thanks, Ivan.
Yeah. Thank you for opportunity to talk here also.
Maybe if people want to find you, what's the best way? I think we shared your blog, right? So they can follow you there or
Yeah, blog, I don't know, or
LinkedIn.
LinkedIn.
Okay. I think I
What?
saw your link. So in the blog, if I scroll down, I saw your
Mm.
GitHub and
Yeah,
LinkedIn.
yeah, also.
Yeah. Okay.
Okay.
Okay then. Yeah. Thanks a lot
Mm.
and